All right, guys. So this is chapter 14, lecture 2. What we're going to be focusing on here is we're just going to quickly identify how various sectors of society use water. So essentially what percent is used by agriculture versus industry versus household use, etc. We'll then go into various types of irrigation and their relative efficiencies, and then we'll discuss some of the pros and cons of dams, as I mentioned we would do back in the energy unit. Okay. So residential use or household use accounts for about 9% of total freshwater use. And this is in the United States, by the way. These numbers would be different in other countries, but this probably represents most of the industrialized world. Okay, so in the U.S., residential use is about 9%. So most of your water is not for drinking and cooking. We actually use a relatively small amount of that. Most of it goes into, your toilet use, your showers, cooking or cleaning, etc. Okay, and I suppose if you count lawns and stuff like that, that number would go up a little bit, but only certain times of the year. All right. So residential use is actually a relatively small fraction of overall freshwater use. Much bigger use is industrial. So about 44% of the water in the United States goes to industrial uses. And that could be for things like transport of goods, cooling. So we use them for energy production. Industrial processes, water has a high specific heat, so it's able to absorb a lot of heat from other processes and using the cooling process. We of course use it for waste disposal, and then in the manufacturing of steel, for example. So if you look at the amount of steel needed to build just a home washing machine, clothes washer, we get about 15,000 liters of water just for the steel in that washer. All right. And then, of course, in mining and refining natural resources, we use a fair amount of water for that. So, industrial sector, significantly larger than household use. But our biggest water user is agriculture. And that's, of course, primarily used for irrigation. Of course, I suppose our livestock needs to drink water as well. But the vast majority of the agriculture goes to irrigating crops. Okay? And so we're going to talk about 3 different types of irrigation and their relative efficiencies. Now, there are other types like drip irrigation that we'll get to later in the chapter when we talk about water conservation. These are our 3 primary types of irrigation used in agriculture. Okay, so flood irrigation. So this is inexpensive, pretty low tech. So if you have flat ground, so the way flood irrigation works is they will send water from they'll divert water from a reservoir or a nearby river into these irrigation ditches. So this is usually a concrete lined ditch. Sometimes they're just dirt lined, but usually concrete lined, right? They'll fill these irrigation ditches up with water, and then the farmer is allowed a certain number of what they call acre feet. Okay. So an acre foot of water is just the amount of water, it's enough water to cover 1 acre of land, 12 inches deep with water. All right. And this goes to any type of irrigation. So water rights are actually divvied out in what's called acre feet for farmers. Anyways, so a farmer's allotted a certain amount of water out of that irrigation ditch. They open up these little hatches and essentially just flood the low-lying land that needs to be flat nearby. As you can imagine, this is not by any means an efficient process. This is often done in arid areas, interestingly, where upwards of 50% of the water used in flood irrigation is just lost to evaporation. It doesn't benefit the farmer at all. Okay? It actually also leads to soil problems. Okay? Primarily in the form of buildup of salts, but that's another issue we'll talk about in the next chapter. All right. Furrow irrigation, it's actually just a type of flood irrigation. It's a little more efficient because they're not flooding the entire area. They're flooding these furrows, and that allows the ground to absorb more, and we get a little bit less evaporation. Still only effective on flat ground. It still has a relatively high evaporation rate. But yes, it is a little more efficient than just your traditional flood the whole ground type of irrigation. All right. And then much better, but also much more expensive is this overhead irrigation. And the most common type is like what they call a central pivot. And so oftentimes, like if you're in an airplane and you see these circular plots, of irrigation, or not of irrigation, of crops. That's that center pivot irrigation. So they have a center pivot and then a sprinkler system that goes out. And then that sprinkler system is able to circle around that pivot, right? So they're able to irrigate in these circular patterns. And sometimes if you look at like farmland from overhead, instead of seeing square plots, you see circular plots. And that's where they're doing this center pivot overhead irrigation. Nice thing about this type of irrigation, it's effective on either flat or hilly terrain. You lose much less water to evaporation. Okay? And as long as it's not done in really windy areas, you're kind of delivering the water right where it's needed. And it's not just flooding. It's kind of directly delivered to the plants, and you can kind of control the quantities a little bit better this way as well. So much more expensive for the initial infrastructure, etc., but also much more efficient in the long run. Okay. Now, moving on to dams and reservoirs. We did talk a little bit about dams back in the last chapter on energy. So some other benefits of dams besides electricity production. One of those is these big reservoirs that get built up behind the dams, right? What this does is it allows us to kind of control how fast the water is delivered downstream. Okay, so by having these big reservoirs, we've got a big backup of water. So we fill these reservoirs up and then kind of let water move downstream at a controlled rate. Traditional river without dams and stuff, you get a big storm or that spring melt off and all that water rushes out to the ocean. And then in the summertime, we're left with just whatever excess runoff there is from snowpack. With these reservoirs, we're able to kind of bank our water. Okay. They help with flood regulation. So again, we can, because these reservoirs, it's a big absorber of water. So we can fill these reservoirs up to a certain capacity to absorb those rapid runoff and help prevent flooding downstream. And of course, they generate electricity. And lots of our reservoirs are also national recreation areas. So lots of boating, water skiing, fishing, etc. in these reservoirs. Now, disadvantage, which we'll go into more detail, of course, would be if they do alter the ecosystem. So when you put up a dam and you're flooding a bunch of areas upstream initially where that reservoir fills up, and they also affect sediment load. And we'll talk about those here in a little bit more. So the Glen Canyon Dam on the Colorado River. So its regulated flow has changed the ecosystem. So if you go downstream from the dam, so essentially, rivers transport mass quantities of sediment downstream, right? And during flooding, it deposits those sediments out in these floodplains and makes nice level floodplains that have really good soil, and nutrients get transported this way. Well, if we put a dam in this river, we're essentially not allowing those sediments to get past that dam. And so they get built up in the reservoir, and then we get erosion downstream. So normally, where we'd have these little sandbars, which are really important habitat and so on, for birds, etc., those begin to erode because they're not getting the replacement sediments to keep those sandbars built up. So moving water erodes the sandbars away. New sediments don't come in to take their place. All right? And again, we get this slow erosion process. We lose habitat, and we also lose nutrients and sediments downstream where we need them for agriculture and things like that. All right? So one of the things they did to rectify the situation was they began allowing controlled floods. So particularly in the springtime when the river upstream of the dam is carrying large loads of sediment, they let some of that water spill through at a pretty rapid rate, and that keeps the sediments churned up like a normal river flow would, and that returns some of those sediments downstream and rebuilt those sandbars. All right? So you guys kind of see that we're going to talk about a lot of the initial problems with dams, but then we'll also talk about some of the things that the Corps of Engineers has done to try to limit those negative impacts. And, say what you want about dams. I'm not a big fan of them personally, but the Corps of Engineers have done as much as they can to try to limit the damage caused by them. And this is one of those cases where they're able to restore some of that sediment load in those sandbars and also keep the dam at the same time. All right. Now, what we know dams for mostly around here, of course, is the disruption of fish migration. All right. So things like salmon, they have to swim upstream hundreds of miles back to their spawning ground. These big concrete walls make it really difficult for those fish to migrate. And so what's shown in this picture here is what's called a fish ladder. It's a bypass. All right. So our native fish populations in the Columbia River and its tributaries like the Snake River have declined pretty drastically because of dams. All right. So because of things like the Endangered Species Act and so on, and we're responsible for making sure that we try to build these populations back up. And so they installed these fish ladders. So you could picture the dam over here. I think this is in the Dalles, by the way. So this is pretty local. Not a very far drive, but dams over here in the main river. There's these ladders, right, or a bypass around that dam out of the main channel of the river, and the fish can just simply hop up this ladder up and around the dam and then swim upstream like normal. All right. What they found with the fish ladders is they do help. They absolutely do help, particularly with the upstream battle. What they found is as the fish work their way back downstream, they're not going back down the ladders. The baby fish are getting ground up in the turbines, unfortunately. So fairly effective. They do help, but they have not gone anywhere near replacing populations to what they were before the dams were built. So a couple really important kind of hot point dams. One of the three is the Three Gorges Dam in China, fairly recently built. You can see this gigantic reservoir there. It was fairly controversial because, first of all, it's the world's largest dam. Second, world's largest energy producer. It ended up displacing a few million people. It flooded some important archaeological sites, and it also flooded some productive farmland, which again, we always find along our river deltas. Okay? 1.13 million people just had to up and leave because the Chinese government decided they wanted to build this dam. But the plus side of that is it produces enough power to replace several coal plants, which reduces air pollution, which has been a major problem in China. Some other disadvantages, lower nutrient transport. So just like the sediments get blocked, so do nutrients sometimes. And that affects agriculture, of course, but it also affects the transport of nutrients to the ocean. And they noticed the precipitous decline in fish catch along coastal areas. And that's primarily cited to the High Aswan Dam on the Nile River in Egypt. The catch of sardines declined drastically after putting the High Aswan Dam. And when you stop moving the water, right, so you put it in a reservoir, particularly in our hot climates, we're going to increase water temperatures. And with higher temperatures, we get decreases in dissolved oxygen, and also makes it potentially easier for some diseases and parasites to breed and spread. All right. Like I said, this is going to be relatively short this time, but that kind of just takes us through a little farther. Talks us about pluses and minuses of dams, talks a little bit about the various sectors of society and how we use water, and we also discuss the different types of irrigation. All right. See you next time.